Hi friends. In the previous video, I was already explained the memory organization of 8051 microcontroller, right? So in that I mentioned that the internal RAM is divided into three parts. Internal RAM of 128 bytes divided into three parts. So general purpose registers, bit addressable registers, and some are direct and indirect addressing mode registers, right? Let us see here. In this particular video, I am giving you briefly the registers of 8051. What are the various registers of 8051? Nothing but register organization of 8051. We'll see detailedly. Okay. See here. So if you observe carefully, 8051 microcontroller having set of 8-bit as well as set of 16-bit registers. Here the left side A, B, R0 to R7, SP, PSW all comes under 8-bit family. Here some 8-bit registers of 8051. Whereas DPTR and PC comes under 16-bit family. So two 16-bit registers are present in 8051 microcontroller, and similarly see here R0 to R7, AB, total 10, SP and PSW, 12 8-bit registers are present. So preferably for all programming point of view, so we are mainly using, see here, so in majority of the programming we are using AB, similarly R0 to R7, all are called as general purpose registers. Okay, whereas SP, PSW, they are used for some special functions. We'll see detailedly here. Right. First, coming to first one, A register. You know what is A register? It's accumulator register. And accumulator register is used as a destination register for all arithmetic and logical operations. Okay, it is an 8-bit register. And additionally, the accumulator register is having provision and it can access data from any of the memory. Okay, maybe internal RAM memory or internal ROM or external RAM or external ROM. So only accumulator register can communicate it to memories. Okay, that's another advantage of accumulator register. And it is used as a default register, or it is used as a default register for all arithmetic and logical operations as a destination register. Now coming to B register. B register is another 8-bit register used for all general operations. All arithmetic and logical operations, we need one register, okay, as a source operand. Okay, in that case, generally we are using B register, preferably for all general operations. Then R0 to R7 are called as another general purpose registers are available under the internal RAM area, because internal RAM already having total 128 bytes. In that 128 bytes, they are dividing in the form of general purpose register area. So in that area, we are using R0 and R7. And these R0 to R7, we are selecting under bank 0 or bank 1 or bank 2 or bank 3. That is decided by program status code. Okay, in program status code, I will give you briefly how we can select bank 0, bank 1 and bank 2 and bank 3 and how R0 to R7 registers are present. But preferably R0 to R7 registers are also used like a general purpose registers for all general programming part. And SP is a stack pointer. Stack pointer is a stack point register, and it is related to stack operations, nothing but push and pop operation. And whenever if any reset is occur, stack pointer is pointed out at the location 07H. And for every 8-bit push operation, stack pointer is incrementing by one location. And for every 8-bit pop operation, stack pointer is decrementing by one location. Like that, stack pointer always point out the top of the stack. Okay, and stack performs two functions, push and pop. And for every 8-bit push operation, stack pointer is incrementing by one. And for every 8-bit pop operation, stack pointer is decrementing by one. And whenever reset is occurred, stack pointer is pointed out at the location 07H. Okay, program status code we'll discuss at the end of the video. Okay, detailedly. Okay, similarly DPTR. DPTR is a data pointer register. It's a 16-bit register, and this DPTR is divided into two parts, DPL and DPH. Okay, it's also a general purpose 16-bit register. Okay, so now it is divided into two 8-bit registers, DPL and DPH. Name is data pointer lower byte register, data pointer higher byte register. So for 8-bit requirement is there, then we can use DPL and DPH in addition to AB and R0 to R7. We can use only this DPTR is having provision divided into two 8-bit. And one more is for accessing internal ROM memory selection, for selecting the address of internal ROM. Similarly, the address of external RAM and external ROM, it is possible with the help of DPTR register only. Okay, then other is PC. PC is a program control register. and program control register is also 16-bit register, and this program control register always point out the address of the current instruction is being executed. So which instruction a processor is currently executing, that information is present, that address is present in the program control register. Okay, like that we can analyze the registers. Now let us see general purpose registers. I already mentioned the internal RAM divided into 3 portions of memories. One is called as a general purpose registers. So what is the size of general purpose registers? In the previous video I mentioned 32 bytes, 00 to 1F. 00 to 1F is the internal general purpose registers area of internal RAM memory, general purpose registers area of internal RAM. So that 32 bytes are divided in the form of 4 banks, bank 0, bank 1, bank 2 and bank 3. Let us see here 4 register banks. Each bank has R0 to R7 selected based on a program status word of bit 3 and bit 4. So in order to select these 4 banks, we use program status word register. In that bits program status word nothing but flag register. Flag register bit 3 and bit 4 are used to select either the bank 0 or bank 1 or bank 2 and bank 3. So at the end of this particular video, I will explain program status word. In that I will show you bit 3 and bit 4 and how these 2 bits are used to select banks of internal RAM area easily. And remember, general purpose registers are having total 32 bytes. 32 bytes are divided in the form of 4 banks, bank 0, bank 1, bank 2 and bank 3. Each bank having 8 registers, 8-bit registers, R0 to R7. So R0 is address of R0 register is 00 and address of R7 register is 07. Like that 8 registers are present in each bank. Bank 1 also same R0 to R7. Similarly bank 2 also R0 to R7. Bank 3 also R0 to R7. But at a time 8051 microcontroller takes only one bank at a time. Either bank 0 or 1 or 2 or 3. That's why what are the effective registers? Only one set of R0 to R7 only effective for every operation. Okay, so whether we are selecting bank 0 to bank 3 is decided by program status word 3rd bit and 4th bit. Okay, like that general purpose registers are there. Total 32 bytes are decided into 4 banks and each bank having 8 registers and size of each register is 8 bit. Like that, in addition to accumulator register and B register, 8051 also having 8 general purpose registers R0 to R7 in any of the bank. Okay, but at a time only one bank will operate. Only 8051 may select only one bank at a time. Okay, it is not possible to select all 4 banks at a time. Okay, okay, this part is called as a general purpose register. So out of 128 bytes of internal RAM, 32 bytes related to general purpose registers. Next, let us see other. What are the other? Now let us say other one is bit addressable memory. Is another part of the internal RAM. So what is the size of bit addressable memory? 16 bytes. Starts from previous one is end at 1F, right? Now next one starts at 20, end at 2F. 20 to 2F. Here how many bytes are present? 16 bytes are present. So previously 32, now next is 16 bytes are present. Okay, what is bit addressable memory in for serial port operations? We have individual bits we are transmitting. Okay, individual bits we are receiving. Because now 8051 is ready to performing serial port operations also. In that we are transmitting instead of parallelly, we are transmitting like a individual bits. In that case, bit addressable memory is also important. So in that particular case, what happens? We have 16 bytes. 16 bytes of memory locations are there, and each byte having 8 individual bits. Okay, 8 bits are there. Like that, this memory having 8 bytes. Sorry, this memory byte having 8 individual bits. Another memory also 8 individual bits. Like that, last one also 8. Total 8 into 16 means 8 into 16 means 128 bytes. Nothing but 20H to 2FH contains how many bits? 20H to 2FH contains how many bits? 128 individual bits are present. 128 individual bits are present. Now let's suppose, for example, this is bit 0. This bit 0 having bit address is 00H and its byte address is 21H. Similarly, for example, assume this is D0, D1, D2, D3 like that, D7. For example, D7 bit address is 07H and byte address is 21H. So for all these 8 bits, byte address is same and bit address is changing. Okay. Similarly, for this is okay. This is another bit in the second byte. Okay. Here the corresponding bit address is 0F and byte address is 22H. Like that. So in this particular area, 16 bytes are present and every byte having 8 individual bits and every bit having individually bit address as well as byte address. Like that, we have 16 bytes are present. So that comes under which family? Bit addressable memory family. Okay, like the second is 16 bytes related to bit addressable memory. Coming to third one is a general purpose RAM. In the previous case, we observed up to 2F, nothing but 20 to 2F. Here starts with 28, but actually it starts from 20. So 20 to 2F related to bit addressable locations. Then 30 to 7F remaining. 30 to 7F hardly 80 bytes are present. 30 to 7F contains 80 because total 128. In that 32 bytes related to general purpose registers, first part. Next 16 bytes related to bit addressable. 32 plus 16, 48 over. Then 80 remaining out of 128, remaining 80. 80 related to general purpose RAM. Means for writing any program, we need some locations. Okay, for sending data to internal RAM or internal RAM. For that we need some locations. So now these 80 bytes starts from 30H to 7FH related to general purpose RAM area. Okay, these locations are used preferably for sending the data, for sending the result into locations. 30H to 7F related to general purpose RAM area. Okay, so like that 128 bytes are divided into general purpose RAM area, bit addressable area, and general purpose registers area, like that. Now after 7F, there is called it as upper 128 bytes of RAM. Let us see what is that. Okay, that is actually inactive position. Here after 80, after 7F, here 00 to 7F, we already observed. First 32 bytes related general purpose registers, next 16 related to bit addressable memory, next 80, 30 to 7F related to direct and indirect addressing mode, nothing but general purpose program area. Next 80 to FF, nothing but another 128 bytes. Those are called as upper 128 bytes of RAM. Okay, those locations are preferably used for indirect addressing mode of operation. Okay, so in this mode we have special functional registers are present. Similarly, some data registers are present. Similarly, some control registers, nothing but for timer operation, serial port operation, interrupt related operations, analog to digital, digital to analog, etc. All those related registers are present in this upper 128 RAM locations. The upper 128 bytes of RAM location contains different set of registers like timer related, serial port related, interrupt related. Okay, so but these locations we are not using in a general purpose programming part. Okay, these locations preferably contains address of all these registers. Okay, like that we have special functional registers are also present in this 128 bytes of RAM. Some special functional registers are present like TCON, TMOD, SCON, PCON, IP, IE, TH0, TH1, TL0, TH0, TL0, TH0, like that. So some special functional registers are there. In addition to that, we have timer register, serial port, all comes under these 128 bytes. Okay. So anyway, we'll discuss all those special functional registers okay, at the end of this particular microcontroller topics. Okay. Then other important one is a program status word. Let us concentrate. What is program status word? Here program status word. I will take highlighter. Program status word also call it as a flag register of 8051. So it is an 8-bit register. Assume this is a program status word 0th bit, bit 1, bit 2, bit 3, bit 4, 5, 6, 7. Okay, now let us see. First D0 is a priority flag. So when priority flag is 1, whenever the result contains even number of ones, then priority flag is set to 1. When the result contains even number of ones, then priority flag is set to 1. Then OV is overflow flag. When overflow flag is set to 1, when results are out of range, nothing but there are two conditions. If any condition is true, then overflow flag is set to 1. In 8086 also I mentioned. So when overflow flag is set to 1, whenever carry into MSB bit and no carry out of MSB bit, in that case overflow flag is 1, or no carry into MSB bit and carry out of MSB bit, in that case also overflow flag is 1. Like that we observed overflow flag. This is overflow flag. It is occurred when results are out of range. Then RS0 and RS1, these two pins, call it as a program status word, because total is program status word. This is program status word 3rd bit and 4th bit as per count. 0th bit 1, 2, 3, 4, like that. Program status 3rd bit and 4th bit are used to select individual banks. We have 4 banks are present in internal RAM of general purpose registers. In order to select individual banks, we use R7, RS0 and RS1. See here, RS1, RS0, 00, 01, 10, 11. If it is both are 00, then we are selecting bank 0. Register bank is bank 0, bank 1, bank 2, bank 3. If it is bank 0, what is the address range? bank 0 size, because each bank is having 8 bytes. So address of bank 0 is 00 to 7, 00 to 07, nothing but 8 bytes. Bank 1 after 07, 08 to 0F. Here also 8 bytes, 8 bytes, 8 bytes, like that, 32 bytes related to general purpose registers. So, but at a time, how many banks we are selecting? Only one bank based on the selection of RS1 and RS0 bits. That's why with the help of this RS1 and RS0, we can select individual banks of internal RAM memory, bank 0 to bank 3. Each bank having 8 registers, R0 to R7. Like that, at a time, we are taking one set of R0 to R7 registers. Then F0. What is F0? It's a, here F0 name is flag 0 register, or flag 0 actually. It's a flag 0, nothing but 0 flag. So whenever result contains all zeros, then 0 flag is effective. AC. What is AC? Auxiliary carry flag. So when auxiliary carry flag is set to 1, whenever auxiliary carry flag is set to 1, when carry is moved from third bit to fourth bit. Okay, whenever a third bit, if you perform addition or subtraction, in that case, whenever carry is moved from third bit to fourth bit, then auxiliary carry flag is set to 1. Next, carry flag. When carry flag is set to 1, when carry comes out of MSB bit, then we can say that carry is occurred. In that time, carry flag is set to 1. Like that, we have few flags are present in program status code, and those flags are affecting based on the arithmetic and logical operations are performed by ALU unit, and these two are mainly used to set or reset. Whenever RS0 and RS1 are set or reset with the help of program. Whenever RS0 and RS1 both are set means both are ones, then our selected bank is bank 3. Both are reset, our selected bank is bank 0. One is set and other is reset. Then we can select either bank 1 or bank 2, depending on the RS0 and RS1, which is set and which is reset. Like that, we have registers are present finally. So finally, what is your observation? If you observed 8051 microcontroller, mainly we have some registers are 8-bit registers and some registers are 16-bit registers. And for writing any program, we need preferably accumulator register, base B register, then R0 to R7 registers preferably. In addition to that, we need a DPTR 16-bit register also. Okay, so like that, we can analyze the functioning of each register effectively. Right? So thank you for watching this video. If really like, please kindly subscribe my channel. Right? Thank you.